Yes, nothing like a little jazzy music to get you into a learning spirit. Greetings and welcome to the Advanced Hydronics College of Hydronic Knowledge, Domestic Hot Water Supply and Distribution Basics. I am Mark Etherton. I will be your course curator. On the screen is the Denver Health Standard for domestic hot water heating systems. It states that heating and hot water heating facilities shall be in every dwelling and shall have supplied hot water that are installed in accordance with the Housing Code and the Denver Building Department and Fire Code are maintained and operated in a good condition. Basically, what this is telling us is that we have to provide a minimum of 120 degree Fahrenheit water to all points of use in the building, with the exception of facilities provided assisted living that have a completely different standard. Domestic hot water heating systems come in all different types, sizes, shapes, and configurations. Shown is a large commercial copper fin tube boiler that is typically tied to a storage tank, but not always necessarily. They do make one of these units that is fully modulating that does not require a storage tank. Domestic hot water heating can be done either directly with a copper fin tube boiler, or it may also be done indirectly with an indirect or a reverse indirect type of storage tank that utilizes a closed loop space heating boiler as its heat source. This is another configuration of a copper fin tube boiler. And yet another configuration. This particular boiler also has an integral bronze pump. And yet another configuration. This particular boiler is manufactured for applications in exterior settings and obviously has to be covered with the use of glycol, so it would be virtually impossible to do a direct domestic hot water heating system with this particular boiler, especially in Colorado's climates. Depicted is a typical indirect domestic hot water storage tank. It has a large volume storage tank that varies between 40 and 119 gallons, and it has an internal immersed coil through which closed loop hot water is circulated. It can be used as a solar domestic hot water preheat, but is more commonly used with a boiler as its heat source. Note that the heated water enters through the top of the heat exchanger and the less hot water comes out of the bottom, while the cold water enters the bottom of the storage tank and the hot water exits out of the top. This is basically a counterflow condition that extracts the maximum amount of heat available from the heat source. It is important to also note that this system requires an entering water temperature of 180 degrees Fahrenheit and will typically realize a 20 degree Fahrenheit drop in temperature, so the return water will come back at 160, which is out of the range of condensing for most high efficiency appliances. Depicted is a cutaway of a reverse indirect type of domestic hot water storage tank. The system does require a heat source, a hydronic heat source. It could be either a ground source heat pump or a hydronic boiler. The major difference between this and an indirect storage tank is the amount of surface for the heat exchange process itself. In this case, you run water through the tank from the boiler or the heat source, and then you run your potable water through the copper coils that are shown on the inside of the tank. This system is also a counterflow type of design, whereby the cold potable water enters the bottom of the storage tank through the copper heat exchangers, and the boiler water enters from the top of the tank, and essentially those two flows go counter to each other, with the hot water going down and the potable cold water coming in from the bottom and going up and picking up heat from the heat source itself. The key advantage of this type of system is that with the large surface area, it only requires an approach water temperature from the heat source, typically only 10 degrees hotter than your desired water tank temperature. So if you need 130 degree Fahrenheit water, then essentially you have to hit it with 140 degree Fahrenheit boiler water, which will result in a return water temperature back to the heat source that will and can cause condensing. This is fine if you have a condensing appliance. If you do not have a condensing appliance, you have to be careful that you do not create any long-term condensation production issues that will become a problem with the maintenance and operation of the heat source itself. Now depicted on the screen is a triangle tube smart tank. This is a tank within a tank design. It is important to follow the manufacturer's instructions as it pertains to filling. They require that the inner tank be filled first before you fill and pressurize the outer tank, which basically is the annulus between the internal stainless tank and the outer mild steel tank. One distinct disadvantage of this tank is the fact that it depends solely upon thermal conductivity between the outer fluid in the hot tank and the inner fluid of domestic hot water to transfer heat. This tank has a tendency to stratify, meaning that the hottest water will always be at the top and the coldest water will always be at the bottom. It's important that the sensor be firmly bedded all the way down in the bottom of the sensor well in order for this storage tank to work correctly. Per the manufacturer's instructions, this is also a counterflow type of heater, with the hot water being introduced to tapping E on this drawing, and then the return water going back to the boiler through tapping D. So it would be a situation where the potable water is going in the exact opposite direction as the heat source water. Now showing on the screen is a flat plate heat exchanger, also known as brazed plate. Although this is a very efficient method of heat transfer, its transfer efficiency is based on the fact that it has significant surface area for the heat exchanger surfaces themselves. It is important that the fluids be counterflowed. In other words, your potable water needs to go through this in the opposite direction as your heat source water. And it also is complicated by the fact that it requires a secondary pump to extract heat from the heat exchanger and transfer it into the storage tank. These are not very common, but it is one method of domestic hot water heating that can work rather efficiently. When installing this type of heat exchanger, it's important to provide adequate isolation and purge caulks so that a chemical solution can be circulated through the flat plate heat exchanger to remove any scale accumulations that may have occurred over the years. These components are the required minimum components for a domestic hot water distribution system. You have the domestic hot water storage tank, also known as the indirect or the reverse indirect. You will have a point of generation anti-scald tempering valve. You could possibly have a point of use anti-scald tempering valve, and then you should have a domestic hot water circulation system if the source and the load have more than 25 feet of separation between them. Now showing is a parallel direct return domestic hot water supply and recirculation return system. As you can see, the supply and the return go in opposite directions each other, hence the direct return method. Each one of the horizontal lines indicates a floor. The vertical red lines would be the hot water mains that start out from the bottom floor and typically reduce in size as they drop branches, headed for the very top. At the very top of the system is the beginning of the circulation return lines. Water, being wet, lazy, and stupid, is going to have a tendency to follow the path of least resistance, so that those branches that are on the left-hand side are going to have a tendency to flow significantly less than those branches that are on the right-hand side. One potential solution to the problem of the water flowing through the path of least resistance would be to install a thermal balancing valve like a Calefi at the very top of each one of these hot water supply risers, so that as the hot water gets to that riser, the valve pinches down to its minimum setting and allows the flow to be balanced throughout the system as a whole. This drawing depicts a parallel reverse return piping configuration with the same multiple floor multifamily dwelling application. The hot water supply main flows from right to left. The risers take the hot water up to the very top of the system where the beginning of the reverse return header begins. The return header also flows in the same direction as the hot water supplying into it, and then reverses and goes back down to the domestic hot water heating system source. This system is not as susceptible to problems associated with imbalances in flow. However, it too is also subject to the possibility of having hydraulic erosion occurring within the piping system itself. Typically, that second to the last branch on the very top of the system is going to be ½ inch. If the circulation return pump is oversized, it is going to cause water velocities such that hydraulic erosion is a guaranteed process. By having, again, the thermal Cleffi balancing valves in there, it will basically slow the flow down to the minimum to maintain thermal structure within the actual distribution system itself and avoid the possibility of hydraulic erosion. This is a pyramidic return system. Essentially, the hot water supply main runs horizontally, and then all of the vertical branches would be the risers that would go up through the apartment complexes themselves, and then they would hit a header at the top, which would be the circulation return header. But on the left-hand side, it flows from left to right to the center, and the right-hand side would flow from right to left to the center. The problems of imbalance should be pretty obvious. Water being wet, lazy, and stupid is going to follow those paths, which are the path of least resistance, which would have a tendency to be essentially the middle third of the risers within that picture itself. The outer edges on the left and the outer edges of the risers on the right are going to have a tendency to have poor flow, and consequently the people will be complaining about no instantaneously available hot water. This is without a doubt the least preferred method of piping a domestic hot water circulation return system, but again, it can be corrected with the Cleffi 116 series thermal balancing valves. The recommended operating temperature limitations are generally dictated by the authority having jurisdiction. In this case, it's dictated by the Denver Health Department. Their minimum recommended water operating temperatures is 120 degrees Fahrenheit to the furthest point of use, and it must be readily available within 10 seconds of having opened the tap. As it pertains to avoiding the production of waterborne bacteria, i.e. Legionella, it's recommended that the storage tank be operated at 130 to 140 degrees Fahrenheit. If the tank is kept at this high of a temperature, it's very important that an ASSE anti-scald mixing valve be installed at the point of generation to guarantee that the discharge temperatures do not exceed 130 degrees Fahrenheit. This chart shows the temperature of ideal growth bacteria and the temperatures where the bacteria is completely killed off. If this is a new heating system, a new domestic hot water distribution system, there should be anti-scald valves at the point of use. And if that is the case, then the distribution system can also be raised up to a scald sanitization temperature that will avoid the production of Legionella within the distribution system itself. Although it's important to maintain a storage tank at a temperature above that, if you are not maintaining the distribution system at an adequately high enough temperature, it is entirely possible that bacteria can survive and, in fact, in some cases, thrive and cause the potential for people contracting Legionnaire's disease. The standards by which the distribution system are scalded dictate that it happen at about 2 o'clock in the morning when the potential for hot water use is at a minimum, and that the temperature of availability be maintained long enough to be able to kill off all of the bacteria, and it typically occurs once every 24 hours. This drawing depicts the distribution system whereby the hot water can be sent out to scald, sanitize the hot water supply mains as well as the circulation return mains. If the Cleffi 116 thermal balancing valve is incorporated, it must have a bypass feature that is electronically actuated by a control within the mechanic room that determines when those valves should be wide open to allow the free circulation of hot water to avoid the production of any bacteria within the piping distribution system. All of the end-use mixing valves must be anti-scald. This is a cutaway image of the point of generation anti-scald device. This device is designed so that if the thermal sensing element fails on the inside of the valve itself, that it is guaranteed to close the hot water port off and allow only cold water to go through the mixing station itself. This is done to avoid the possibility of a scald situation occurring in the event of a thermal element failure, which is a very common failure. This valve must be in compliance with the ASSE standards for point of generation domestic hot water heating systems. This is an example of a point of use anti-scald device, which is typically installed by the plumbing contractor. If all points of use have this type of an anti-scald valve, then it is entirely possible that you can scald the distribution system without worry of creating any scalding conditions at the point of use. This valve must also be ASSE rated for the point of use application. In this drawing, a Legio mixing valve is being used, which can be overridden during the scald sanitization cycle and allow the hottest water available from the storage tank to be circulated through the hot water supply mains, as well as the circulation return lines. And again, the Series 116 valve must have the electronic operator on it, which would be actuated to allow that hottest water to be able to freely circulate through the circulation return lines and not be restricted by the thermal element. This is a picture of the Calefi Series 116 thermal balancing valve. The knob on the left is used to set the temperature at which the valve will start shutting down. The white solenoid valve will bypass that thermal setting and allow full flow to go through the valve during scald sanitization. And the thermometer is on our right hand side. This device also comes with an additional check valve that can be piped in series with the valve, but is not required. At this point, I think we should cover some domestic hot water troubleshooting basics. These systems are relatively simple in their design and their configuration, but when they're not working right, it's going to cause the telephone to ring and there will be somebody on the other end of the line that is not a happy camper. Let's start with the basics. Is the domestic hot water heating system on? This should be relatively obvious to most people, but there are some certain systems that you can turn the domestic hot water heating function off based on time of day or being away on vacation. Make certain that it is on. Is the heat source, the boiler in most cases, operational? If the boiler is not firing, you won't have any hot water being produced for either space heating or domestic hot water, but if it's during the summer months, they wouldn't even realize that they had no space heat. Check this to make sure that it is functional. Is the domestic hot water control temperature properly set? The domestic hot water tank should typically be set for around 130 degrees Fahrenheit. Is the tank sensor accurate? If it's a solid state thermistor, there's a possibility of a loose wire connection that would affect the thermistor's reading, or in rare occasions, the thermistor will actually fail. If it's a capillary tube type controller, it's very common for these to fail, i.e. the ones that come in the triangle tube tank. It is always best to check the accuracy of thermistors and capillary tube controllers using a non-surface contact infrared thermometer. Is the circulator between the heat source and the storage tank functional? This is a critical component. If the pump is not moving water between the heat source and the heat exchanger in the storage tank, you will have no heat transfer. Do not depend upon the small little spinny tool that's basically showing you that the windings have an electrical charge, but it does not necessarily indicate that the pump is moving any fluid. That has to be diagnosed and assessed by looking at the temperature differential between the supply and the return. If you use a non-surface contact thermometer on copper pipe, be sure and dull the copper pipe with tape or some other means, otherwise the reflectivity will affect the emissivity and the readings of the thermometer will be wrong. It is important to check the differential in temperature between the supply and return fluid coming from your heat source and going into the storage tank. The typical temperature drop across the storage tank would be 10 to 20 degrees Fahrenheit. If it is greater than that, it's an indication that you have inadequate flow and there may be a solder ball in the impeller or a partially closed valve or a partially air-bound system that is not allowing proper flow. Check this. Is the storage tank truly hot? You need to verify this by checking the water temperature at a tap. And also bear in mind that if there's a tempering valve, mixing valve, between the storage tank and the points of use, that there's a real possibility that that thermal element may have failed. And if it does fail, its function is designed to close the hot water port off so that you get nothing but either cold water or lukewarm water out of the actual tempering valve itself. So check the supply water temperature going into the mixing valve, and then check the supply water temperature after the mixing valve to make sure that it is functioning correctly. If the customer complains that they have to wait a long time and purge a lot of tepid hot water out of their distribution system before they get hot water at the furthest point of use, it's generally an indication that the circulation return pump is non-functional. Check timers, check aquastats, check the pump, and make sure that it's capable of moving water. Check valve have a tendency to fail in both the open and the closed position. If it fails in the open position and the pump is off, the consumer will complain about a roller coaster ride of water temperature at the furthest end of the system. If this is the case, you need to pull the check valve apart and either replace it if it's a spring type or service it if it's a swing type. The reason for the roller coaster ride of temperature is that cold water is charging backwards through the circulation return back to the furthest point of use, which is typically a shower or a bathtub. And essentially the water keeps changing directions. So it comes from the hot, and then it comes from the cold, then it comes from the hot, then it comes from the cold. It's constantly changing. The simple way to test this and confirm it is to close the circulation return line off and see if the temperature stabilizes. If it does, you have a bad check valve. If the customer complains that the storage tank is very slow in recovering, and you see a very low differential in temperature between the supply and the return line, that's an indication that the heat exchanger that's immersed on the inside of the storage tank is completely lime scaled up. This basically retards the flow of heat from the boiler water through the heat exchanger and into the potable water. If that is the case, it will be necessary to treat this heat exchanger with acid in order to remove the lime scale accumulation so that it has good conductivity to the surrounding water. Does the customer's stainless steel storage tank or flat plate heat exchanger have a tendency to fail prematurely? This is a consequence of the highway department using chlorides to de-ice the streets. If the home is on a private well and is located anywhere near Interstate 70 or Highway 285 or I-25 or any major thoroughfare that is de-iced using the chlorides have basically gotten into the aquifer, and those chlorides are causing chloride stress cracking within the stainless steel storage tank or the stainless steel heat exchanger. You will have to replace the storage tank with a steel glass line tank in order to avoid additional failures in the near future. As it pertains to heat exchangers, you will have to use a titanium-based heat exchanger, which is rather expensive. I would consider the alternative of setting a glass-lined steel tank as opposed to trying to find a titanium heat exchanger that can withstand chlorides. Well, this completes the Advanced Hydronics Incorporated College of Hydronic Knowledge Domestic Hot Water Heating Supply and Distribution System Basics. Again, thank you for taking the time to learn, and if you have any questions, feel free to send me an email. I can be reached at m.etherton@advancedhydronics.com, or if you've got my cell phone number, you can give me a call. Thanks again for learning, and remember to continue to pay it forward. Keep your hands clean, your mask on, and your hopes high. We'll be out of this COVID virus one of these days soon. Thanks. Bye.